Okay, this is question number 5 in paper 2. Now, a straight line 4y equals to x plus k is the normal to the curve. Y, you're given a function of y at point A. So when you see the keyword normal curve again, just like number 4, let's sketch this out because this one will guide us on how to do. Now the equation, the straight line is the normal. So let's draw the normal. Normal is like this. And we are given the equation, which is 4y equals to x plus k. So this is the equation of the normal. And then we have the curve, the function of the curve. So we should put the information here, 2x plus 1 squared and then plus 2. At point A, so this is A. What is that point? I don't know. So just put x1, y1. That means can be found, okay? And then for this one, it's always the gradient of tangent. What is the relationship here with all these other two information? It is differentiate this curve, we will get gradient of tangent generally. To be more specific, we will substitute the x into the gradient of tangent. Okay, now, but I do not have this. Even if I differentiate, I just get a general value. But how do I go about? I have extra information of this one, the normal. So from the normal, what is important is if I have gradient of tangent, I can be find the gradient of normal can be found. So but the gradient of normal can be also found from the equation of the normal. So let's write the equation of normal in the gradient form. So this is in the gradient form. So from here, we know that the gradient of normal is actually 1 over 4. If gradient of normal is 1 over 4, therefore the gradient of tangent will be positive, become negative. 1 over 4, the reciprocal will be 4. So I know gradient of tangent is negative 4 over here. So with this, we can find. What do we need to find? The first part, the gradient of the tangent at point A, we just found, isn't it? Okay, we have to show the working, yeah? So part A, show this one. Gradient of normal times gradient of tangent equals to negative 1, all right? And then 1 over 4 times gradient of tangent equals to negative 1. Therefore, gradient of tangent will equals to negative 4. Just show this lah, even though we don't have to show, but since it's part of the question, so we just show in case the working can help us to get some marks from it. Now part B, the coordinates of A and the values of K. So let's continue. Now, since I have gradient of tangent equals to negative 4, so I will relate it to my dy dx, yeah? Gradient of tangent is negative 4. So start with the information. Gradient of tangent equals to negative 4, whereby gradient of tangent is actually dy dx. That means dy dx is also negative 4. So we have to differentiate our y. So what would that be? We will have it's either you expand this, okay, or we apply the chain rule. So do outside. So when we do outside, bring the 2 down. Okay, inside remain, and then followed by we differentiate the inside. The inside is actually 2. So the original is 2x plus 1, yeah? So this will be our, so dy dx equals to negative 4. I should write over here. Okay, never mind, this is equals to negative 4. And then this one we will have, this is 4. Therefore, 4 times 2x plus 1. So you want to find 2x plus 1. Okay, you bring the 4 across. So 2x plus 1 will equals to negative 1. So 2x will equals to negative 1 minus 1, negative 2. Therefore, x will equals to negative 1. Okay, that means I found this to be -1. So once I know that this is -1, how do I find the y? Substitute x equals to -1 into the equation of the curve. So let's continue. We will have 2x plus 1 squared. So y will equals to 2x plus 1 squared, and then plus 2, yeah? Plus 2. So when our x is -1, what happened to our y? So 2 times -1 is -2 plus 1 squared plus 2. We will have -1 after we square become +1. So plus 2, we have 3. So we found our point A right away. -1, 3. Next, what should we do? We need to find, that is part B. We found A, and don't forget we need to find the value of K. How to find value of K? And the same point, it's also passes through the equation of normal. So let's substitute that point, -1, 3, into the equation of the normal. Okay? So substitute -1, 3 into the equation of the normal, that is 4y equals to x plus k. So whenever we see the y, we replace with 3. Whenever we see the x, we replace with -1. Therefore, k will equals to 12 plus 1. So we got 13 as our answer. So we have found the A and we have found the K. Part C, the equation of tangent at point A. So we need to find the equation of this tangent. Okay, where we need to find the equation, we must have two things. One is the gradient of tangent. One is the point. In this case, is point A. With these two, we can solve the equation. Generally, we have the gradient of tangent, which is -4, and the point A, which is -1, 3, and now form the equation. So the equation will be y minus y1 equals to m times x minus x1. Minus -1 become positive. So open up the bracket, -4x minus 4. That is y minus 3. Therefore, y equals to -4x minus 1. So this is the answer for the equation of our tangent.